6, 7. Okay, here's second video for 6-3 part 1, talking about trig functions and real numbers. Here's example 1a. They want to find the sine and cosine of a given angle in radians here. Okay, so here's the technique. You want to draw the angle, and then you want to add or subtract from your markers, whether it be in degrees, 180 or 360, or in radians, pi or 2 pi, to find out what your reference angle is. Well, 2 pi over 3, I know this is a 60, just like we talked about on the last one. It's a pi over 3. So 2 pi over 3, if that's 1 pi over 3, then double that. Boom, there's 2 pi over 3. And what's my reference angle here? Well, pi is the same as 3 pi over 3. You see how the 3's cancel out to be 1? So 3 pi over 3 minus 2 pi over 3, that's like saying what's 3 minus 2? That's equal to 1 pi over 3. That's how it's actually drawn, but we don't draw the 1. So I know this reference angle is a pi over 3. What did I tell you guys last video about pi over 3's? Pi over 3's are 60s, and their coordinates are always like this for x and y coordinate. Always, always, always. But look over here. This angle is in quadrant 2. That means the x coordinate is going to be negative, or the cosine is negative. That makes this one negative. So the cosine is negative 1/2, and the sine is rad 3 over 2. Okay? Oh, I guess the answer should have been down here. The reference angle for 2 pi over 3 is pi over 3, and it's in quadrant 2. Okay, so here are a couple of tries. I got 2 of them right there. Try to find the cosine, the reference angle, and the cosine and sine for those two without cheating and looking at the unit circle. Go ahead and pause and do that. All right, here are the answers. Pi over 6, which makes this one a rad 3 over 2 and negative 1/2 because it's in quadrant 4. And a 4 pi over 3 is, again, it's a pi over 3 reference angle. I know pi over 3's have 1/2 rad 3 over 2, but this one's in quadrant 3, so these angles are both negative. How did you do? That's it for this video.